Swayam Prabha. Digital India. Educated India.
Hello, my name is Atul Tripathi and I'm an honorary adjunct fellow at National Maritime Foundation, and welcome to this lecture series on ESG analytics and green finance. This is the seventh of this entire lecture series, and we are going to be talking about forecasting measures, various indices in terms of air pollution. So today we'll be focusing on health risk index, things like drought index, PM2.5 index, aerosol depth index. What about the hazard mapping, the role of artificial intelligence in hazard mapping, the role of artificial intelligence in stress testing, the role of interplay of GIS with AI for hazard mapping. So let's look at what we're going to be taking today and how we're going to be taking it out from here onwards. So first thing first, we're going to be talking about why do we even need these matrices, forecasting to matrices. What is the importance of it? Why do we even need it? And how is it going to bridge the gap in terms of predictions and the impact that is going to happen? Because you see, by 2050, the climate-related events could cause an annual damages of about $1 trillion globally, and if unmitigated, that is as per Swiss Re Institute. Therefore, you need a very good forecasting accuracy measures. So all the way, the first thing that you do is gathering your forecasting reports, to measuring your actual trends, to figuring out your matrices appropriately and calculations, and finally identifying the various trends. These are various steps involved. So the question happens to be what and when, and that's where the forecasting point. So basically, you're providing the probabilities of future events like rainfall levels, temperature anomalies, storm landfalls, or pollution concentrations, which is very critical for any early warning systems, but it is actually not sufficient enough for any decision-making system in the finance or ESG perspective. However, that's where, what is becoming very important. So you're translating your forecast into an actionable, quantifiable impact, and therefore this entire cycle is very important for anybody. So you're choosing your economic factors such as your infrastructure losses, your agriculture yield reductions, the productivity shocks, to your health-related mortality, respiratory illness-related rates, vector-borne diseases spreads, the changes in corporate governance scores or environmental scores in ESG terms, and regulatory and compliance cost and community displacement indices in terms of the ESG. And why does this actually matter? That's an important point, because investors and insurers and regulators, they don't act on weather alone. They need an impact to be measured on the ground, because they have got capital allocation to be taken care of and the risk and the compliance measures to be taken care of in terms of the capital allocation. And therefore, if you take an example, as a cyclone forecast, it can trigger a deep disaster preparation, or a cycle impact metrics will trigger an insurance payout, or an ESG reporting, or a sovereign risk repricing altogether. So that is why this is becoming a very important matter for finance and ESG. And if you look at it from the strategic relevance, you're building your resilient portfolios, where you are marrying your forecast with the matrices to build the bridges between science and finance altogether. So it's a world of science and finance that you're bridging and bringing up together, because you're measuring you're shifting your enabling of the indexed ESG measures to the parametric insurance and the regulatory risk benchmarking that needs to be taken care of. And without these matrices, the forecast will just remain an alert, and these matrices will just become they'll become financial levers and not become an actionable point for the finance companies. The index climate and ESG measures, that's where you're turning your data into more of an actionable financial signal. So because you see, by 2030, $90 trillion in infrastructure investments will be required for climate alignment as per World Bank. Now, question happens to be, what are these indexes and how do you measure them? What are the factors that you need to take care into consideration? And that is why you see this entire, FTSE Russell's ESG ratings and data model that is there. It has got multiple factors such as ESG rating, the pillar exposure, coming from pillar exposures to the pillar scores to your theme exposure, theme scores and theme indicators. So you have multiple things such as biodiversity to your climate change, pollution and water use and the environmental factor. You have your labor standards, human rights, supply, which is impacting the supply chain on the social factors. And therefore, you have got multiple scores, from good, no disclosures to all the way to the best practices, that is taken care of. And therefore, you get your data that is there, your indexed data that is being turned into an actionable point, and that is why do we even need these index measures, because the current ESG data is completely fragmented, as you can clearly see on this this diagram, and it is inconsistent and it's completely hard to translate into financial signals. Therefore, indexed measures will provide you a standardized, a quantifiable and a comparative metrics altogether. And it is very, very essential for your scaling of the climate finance and the green bonds and the ESG ratings and the risk adjustment returns. This entire perspective has to be taken into consideration where you're turning your climate index into a measurement altogether, because you need investments to be taken care of, which has been measured or indexed against the geo benchmarking, for green bonds, ESG funds, equity funds, and climate alignment infrastructure, and the insurance that is there, where you are enabling your parametric insurance products to figure out your triggers, for the payouts, which will happen automatically rather than being dependent on any factors which has been benchmarked, say rainfall, temperature, UHI. Whenever they're exceeding the threshold limits, the payout is immediate and it's automatic in nature. And the regulators are becoming also very important, because that is where the common yardstick is going to be for disclosure of the framework. So you have the popular frameworks such as TCFD, SEBI's ESG norms or EU's taxonomy. This is resulting in your risk reduction, because there you have the risk reduction in terms of uncertainty for the capital allocation that is bringing in your transparency, because you're lowering your greenwashing risk, because you're tying it up with the performance to independent indices. And the scalability is also becoming important, because that is where you're supporting your green border regulatory convergence and the international's green finance flows. And to be very frank with everybody, it becomes very forward-looking rather than just being an approach and a measures. We'll look at it this point in coming minutes. Where you're indexing your measures, where they're being emerged with backbone as a backbone for sustainable finance infrastructure, and without them, any commitments to the climate will risk. It is only going to be narrative driven instead of being data driven, which is very, very important for any financial organization. And therefore, you have to turn your capital markets and you have to price them, the resilience into every dollar that has been invested and has to be taken care of. Because you see, there are multiple indicators. There are about 300 indicators which is being individually researched, and various aspects have been taken into consideration with focus of the key operational issues. You have themes, 14 themes where the ESG scores and exposures have been taken care of against the various ESG pillars such as climate change, anti-corruption, something we have measured out here. And you have 3 different pillars. A cumulative score is being taken care of, so as to have each of the environmental and social and the governance factors. And then finally you come down to your ESG rating, which is giving you a cumulative calculation of the total ESG performance itself. So why do we need to have an extreme weather prediction with the air pollution? Because that's about 7 million premature deaths. That's the reason why we are looking at. That's a huge number across the world. 7 million is a very, very large number, because weather events are actually amplifying your pollution exposure, and that is where the heat waves are increasing. Because of that, PM 2.5 is actually going up, and mortality rates are also going up by about 21%. This is as per the Lancet Planetary Health Record 2023. So what's actually happening is that the extreme weather is intensifying the pollution, because the heat waves are accelerating your ozone formation, resulting in the wildfire, which is injecting your 2.5 into cities, and which are about, they may not be very close to the area where the wildfire is taking place. It can be across the board. It can be thousands of kilometers away from where the wildfire is actually happening. Dust storms, again, raising a particular area or becoming a very big issue in terms of the arid regions. And that's where the synergization of effects has started to take place, because the pollution-related health deaths have increased by 10 to 20% during the extreme weather condition. Because measuring these weathers and air pollution together is not a science. It's about foundation of designing the financial instruments along with the impact that it can have on cost of saving lives and economies in the real time terms. And PM 2.5, what actually it means, it is actually causing your major problems like in cardiovascular diseases and in terms of your respiratory diseases. And NO2 and oxygen basically linked to asthma, chronic health lung diseases. And this is all climate driven multipliers, because as your heat index goes up, so does your admission in the hospitals goes up. This is very correlated studies that have happened in the past, and it's continuously happening. So stagnated air masses are trapping your pollutants, extending the exposure duration, resulting in the higher problems in terms of health infrastructure. And therefore, you'll find it again in terms of coming back to the financial part of it, your health bonds, they're being issued, which have been issued to the funded pollution migration infrastructure, is being priced based using the mortality risk indices. Your parametric health insurance is being triggered. The triggers are being paid out based on the pollution and the excessive heat, which is critical for the certain threshold levels. Your ESG portfolios are being adjusted based on your climate air pollution risk index, which is called as CAPRI. Climate air pollution risk index. So and there are a good number of platforms that are available across the board. So let's start looking at a few of them. Let's look at the first one. Which you can play around with. Look at this. This is a very, very interesting platform by World Health Organization, which is talking specifically in terms of the air pollution. So you can look at the various parameters of air exposures and the household air exposure looking at. Now, I had opened previously a few of them. Let's look at this, since we are talking about 2.5, PM 2.5. So if you hover around any of the countries mentioned out here, let's take the case of China or India. So they're mentioning how much is the impact that is there. Look at the green. The darker the green, the higher is the PM 2.5 impact. So if you look at Russia versus Greenland versus some of the South American and the African countries. Now this is again related to the geography, because you see most of the countries are in and around the equator. You can also filter it based on your data, which is right now the latest one. You can base it on the UN regions. What about, like, say, sub-Saharan African region? Do you want to have an urban thing or a total? What about the health indicators? You can look at multiple factors. So there are multiple filters that you can apply, and you can play around with them based on your requirements. You can look at the various data, countries, residence areas. So this is for people who are very interested in understanding this area of the impact of factors in terms of the health and the parameters. There's another one that is very popular, and is from WHO Air Quality. You can also visit this website. Here you see you have got various pollutants, and you can, again, when you play around with it, I'm playing around with the PM 2.5, and you can see what is the impact. Again, a good study can be conducted. Look at the various areas, Myanmar and the very dark areas versus North America, which is not that impactful. Again, if you observe, it's again around equator we're looking at. You can also play around, say, with PM10, let the data overload itself. It does a bit of interesting studies, and statistical studies have been conducted around this for the health purposes and for various other parametric bond measurements and financial instruments. So one can do a lot of these kind of work around play around with these platforms. That brings me to another point, is health risk index. Since we have been talking about so many of these things, how is the health risk index correlated to your PM, to your air pollutants, I would say? More specifically, you have the weather data, which is actually coming from your temperature, humidity, wind patterns, heat index. So we just talked about it a few minutes ago, the fact that you have to take all these into consideration. Various sources that can be, as have been mentioned, you can take into consideration. There are various air pollutant data which is available on the internet, and based on that you have the AI models which are fusing into your spatio-temporal grids. You can do that by 1 square kilometer grid you can create, which is where you're deriving your pollution factors such as PM 2.5 multiplied with heat index. That will give you a stagnation index altogether. because the low wind and the high temperatures, all these are there, and then you can generate your health risk index, which is you're predicting your predicted excess deaths or morbidity versus the population at risk. That gives you a very good indicator, and then you can link it with the bonds and the financial instruments around with the health risk index factors. So if you have a HRI of less than 0.2, that's a baseline coupon that has been taken. So approximately about 4% of coupon rate is taken. Anything above HRI greater than 0.5, it's where the issuer will step up your coupon rate. So it's going to go up to 6%, compensating the investors for your rising systemic investors. Then you have the parametric payouts, where the sovereign or the municipal bonds could trigger the resilience funds when the HRI is exceeding certain threshold limits. Again, these are defined based on the cities and the factors, multiple factors with the financial instruments, the financial institutions who are handling these kind of stuff. So this is a very important, health risk index is a very, very important thing. And it is here that the world of artificial intelligence is being fused with weather and pollution data and giving a new insight altogether, not only in terms of what has happened in the past, but also predicting the outcomes altogether. That brings me to another point. Why is this forecasting so important? Because you're turning the weather data into a multidimensional risk intelligence. That's what we talked about a few seconds ago. It's no longer about knowing when will it rain. It's about pricing the economic and the health factors, because integrate weather and climate matrices into financial and health models will reduce your financial shocks by up to 30%. That is as per World Bank. And that's, the traditional paradigm that is there in terms of weather prediction it's all about, it's focusing on what will happen tomorrow. Tell me tomorrow what is going to happen. That's what the question happens to be. However, in today's, it's not about what will happen. It's about actionable insights that one needs to take care of, because you're trying to do your capital allocation or health preparedness. And therefore, this world of AI and GIS with your health data, where you're trying to predict your excess mortality rate with heat waves and pollutions combined together, your economic exposures in terms of crop stresses, the infrastructure damages, the business interruptions, what about the policy matters which are going to trigger off your carbon pricing adjustments or the resilience of the funding. All these factors take into consideration the multidimensional risk quantification. I'll give an example. So if you have a heat index that is greater than 42 degrees centigrade for about 7 days, then you have a health alert is issued immediately based on the AI-based model, which is about, expected to be about 25 deaths per lakh people. Economic losses, if you're looking at it, it's about $500 billion economic crop losses in terms of economy, and financial parameters, if you're looking at the parametric bond coupon jumps all the way from 4% to 6%, something we just saw about this in the slide. And that's where the AI and GIS are becoming enablers, because they're able to predict the models in the real-time integration, index generation, the spatial layering, the hazards and the exposure, the vulnerabilities for multiple hazard risk maps. Your blockchains are becoming important, because there are smart contracts for instant capital flows, which have been tied to various risk indices. That's where weather forecasting is becoming very, very risk intelligence now, and because you're fueling the next generation of financial products, the health insurance, the health reinsurance, and the climate policies that you need to take care of. And that also brings me to another interesting point. How do you do that? You look at the theme and look at the World Bank's two popular platforms. I'll just take it here and look at this out here. So it's out here that you can play around with this, and you can figure out what is the percentage change per capita income in terms of the health and in terms of your change in the air pollutants. That's one of the things. Then there's another platform out here on the same World Bank, which is looking at greenhouse gases emissions, carbon dioxide 2 emissions that have been generated from agri-food systems altogether. So large producers of the world, China, India, America, Brazil, they are becoming big emitters of the greenhouse gases, which is very natural, because if you look at the growth of this graph from all the way, the fluorinated greenhouse gases, F gases that have been emitted from industrial process, it comes all the way from about 1970, which is about 153.34 megatons of carbon dioxide equivalent to right now it's about in the terms of 1.4 kilo megatons of carbon dioxide equivalent. So one can play around with this. You can look at the sustainability, the civic index scores, the space civic index scores you can look at. You can also look at the populations of the fish and the water and the factors and the other factors that you may take into consideration. So another point that brings us to questions: why do we need these indices? It's either perishing or surviving. That's where the world has moved to, because $360 billion in global climate-related losses by 2023 was, and only about 10% has been insured as per the World Bank 2023. So what actually has happening, if you observe this diagram, there's a small scale index farmers, smallholder farmers are using the index insurance, and it's here that the role of GIS, AI, the understanding of the deep understanding of the subject along with your insurance is becoming important, because if you see out here, as soon as the seasonal rainfall or the weather index is triggered, there's a satellite imagery factors that is taking into consideration, because you're looking at average yield for losses on an average area yield indexes are triggered off, because the farmers are getting paid only if the index is falling above or below certain pre-specified threshold or important data, and that is where it is ensuring that they may know how to get a payout. So this is a very interesting payout model or a diagrammatic view of what is happening in terms of your index and the perishing. And why is it important? Because as the climate change is accelerating, your traditional qualitative assessments of environment risks, they're not proving to be adequate enough, because the investors, the insurers, the regulators, they're demanding your index-based, threshold-based measures so that they can quantify the risk altogether. And that's where the index measures are creating actionable insight, because you're able to quantify, you're able to track, and you're able to figure out the geographically relevant areas which are going to be impacted because of the change in the environment and the climate, and what is going to be the payouts in terms of insurance. So it's no more about, as I said, it's no more about figuring out what's to be done or not to be done. It's about figuring it out or either perishing it out completely. This is becoming a catalyst for your climate-aligned investor flows, because your green bonds are now being included in climate risk-adjusted pricing. This has been tied to heat and flood indices. The sovereign and the municipal bonds are seeing the credit downgrades based on indexed climate vulnerability. The indexed measures enabling ESG integration into credit models and asset pricings and portfolio rebalancing. You're then transforming your insurance from reactive to predictive, something that is happening out here. There's no need to do a damage assessment and a payout trigger when an index is crossing a predefined level or a threshold that has been defined. So say, cyclone speed greater than X kilometer per hour, that's not going to be happening. It's supporting the faster liquidity in the post-disaster situations, because you're able to reduce your losses, because you're able to amplify the losses, and you're able to do the recovery. You're bringing down your recovery delays that is there. So one of the areas that in Africa, the risk capacity downgrade in drought index and the urban flooding triggered parametric products piloted have been in India have been one of the few of the some very, very successful examples around this, because this is empowering your regulators with the climate stress tests. The regulatory frameworks such as ECB's climate stress tests or RBI's ESG guidelines, they are now requiring financial instruments to demonstrate, one, the exposure to physical risk indices like your flood zones, temperature anomalies, use of indexed metrics in internal models such as value at risk, credit loss, capital buffers. And that's why, the role of GIS-based systems with AI enabled are becoming very, very important altogether. So index-based matrices are actually de-risking and democratizing your climate finance, because the smallholders and the urban micro-insurers and the developing countries can now access capital and protection based on indexed exposures instead of the complex financial modeling systems that are existing. And that is enabling your mainstreaming of the climate risk into global finance, even in the case of data scarce mainstreaming systems out there. That also brings me to another point, and that is how do we do our ESG stress testing? We have discussed this in past. Now let's get a more detailed view around it, because 90% of the global financial instruments now factor ESG risk into climate adequacy models, but fewer than 40% of you are using AI to do it. This is as per World Economic Forum. So the question happens to be, why do we need a stress testing into an AI-based systems now? Because the traditional stress testing, they are relying primarily on the historical data, simplistic scenarios, Once you have the climate risk and the ESG related shocks, they are actually non-linear and they're cross-sectoral and they're very, very data heavy. That is why AI is enabling you scenario generation from the real-time data, whether in terms of heat waves with commodity distribution combined together as an example, or improving your model accuracy under certain uncertainties. So when you look at the regulatory, they have become very important because the regulatory signals are very, very clear in this regard. Say, take the case of ECB or MAS and BOE. They are now encouraging or requiring at least the AI-based stress testings or the models or tools to be for climate scenarios. The RBI's draft discussion paper on climate stress testing is actually talking of the use of AI for physical and transitioning of the risk modeling. Then you have the use cases across the finance window in terms of banking, insurance, asset management. More about the model types and practice around. We are looking at AI in time series modeling or NLP transformers that are there. So you can look at a large number of documents and can figure out information, extract information at a very high pace, which would have made it very difficult in the current scenarios without the use of artificial intelligence. So AI transformation and green, ESG stress testing it's from regulatory afterthought to a strategic foresight tool that has become, because it is enabling your financial resilience at an age where the climate is completely unpredictable, it is cross-sectoral and it's impacting across the board. And that's where we begin to look at some of the examples around how it is being done. So let's say the case of one of them is urban risk indexing, because by 2050, over 68% of world's population will live in the urban areas and less than 25% of the cities will have an up-to-date risk indexing mechanism as per UN Habitat 2023. So in case of dimensions, if you look at, you'll need an environmental stress, which is going to give you the heat days and the flood risk and the pollution index to socio-economic exposures. We talk about the population density, your informal settlements, poverty aspect. What about the infrastructure that will be at risk? How much is the percentage of infrastructure that is at risk? This is what is bring out these urban index, risk indexing will help you, because it's a composite indexed metric, which is, scoring based on exposures, vulnerability, resilience. It is enabling investment prioritization, insurance pricing, urban planning, early warning system designs, acting on a common language between urban planners, climate scientists, financial institutions, artificial intelligence experts, blockchain experts, GIS experts, because the cities are becoming now the epicenters of the climate and the economic social risk. As we talked about, 68% of the world's population moving to the urban areas. Extreme weather events are intensifying. There is a disproportion in terms of that is affecting the poor in the index cities, and the investors and the insurers need a standardized approach towards this. And that's where the role of ESG and finance and policy is becoming very important, both for the investors so that they can identify the cities with underpriced ESG risk, for the governments because they're able to use the URI, that is urban risk indexing, to drive climate smart urban planning and policy making. Insurers, because now they're able to use index-based products for urban resilience, such as flood parametric insurance. The banks, because they're embedding the URI or urban risk index into the municipal risk bonds. So the main focus is that urban risk indexing is the foundation, where the future of where the capital will be flowing to smart, climate-related smart cities. And it's not just about building a safe building. It's about the entire transformation in the mankind's way we are living in the societies on the whole. And that is where, we need to understand and decode our extreme weathers with the indices, because the return periods and the cyclones are very important factors. So it is not just about the extreme weather. What is happening is more often it is about the energy that is intensifying, and that is why the return periods are becoming important. But first of all, we need to understand what is a return period in itself. The statistical estimate of how an extreme event such as a flood or a heat or a cyclone is going to be expected, and once in 100-year expected flood doesn't mean that once in every century. It can also mean 1% chance of that particular event occurring within the given year itself. The climate change is compressing your return periods, making it even these rare events more and more common across the board, because your ACE, your accumulated climate cyclone energy, which is measuring your seasonal transformation storm, it is strengthening by combining wind speed and durations. And unlike storm counts, your accumulated cyclone energy ACE reflects how destructive a season can be, which is vital for the insurance modeling, catastrophe bonds, urban resilience planning. Because in case of ESG finance, the insurance planning, ACE helps the models with the windstorm and the flood risk. The resilience bonds uses the return periods to trigger out the various payouts. The infrastructure investments is guiding you to design the various standards based on the world, worst case scenarios. The green and the climate risk reporting, this is feeding into the stress testing models. The return periods and the ACE, they are no longer about the static use of the risk metrics. They're dynamic in signals, and that is where one of the very popular platforms which is using this particular approach is coming from this particular platform, aoml.aa.gov.in. So I'll just take you to this one. Look at this. It gives you a complete definition. You can go to this website. You can see what is happening. I've just taken the case of a hurricane out here. So Saffir-Simpson scale has been built up, which talks about the use of the miles per hour, meters per second, and knots. When you look at, then you can look and play around with all kind of things. So I've just opened one of the previous ones. It's about how does this extreme temperature indices for temperature and precipitation across the Hawaii Ocean time series. You can open this thing and see, if you see out here as the approximate 1955, it was less than 0 to now it is by 25, it is much above around 20, 22, 3. And the ocean heat content, how much is rising. So one can obviously play around with this technology and approach. Now another thing one can do as I click on the tropical cyclone climatology, it gives me a complete view of La Nina effect and the tropical climatology. If you see out here, I move from typical El Nino influence to La Nina. So more hurricanes are expected due to less vertical and wind shear, warm and wet areas, fewer vertical. So when I move the scale, it gives me the way it is happening from La Nina influence altogether. So one can check out all these platforms that are available across the board. I will take another case. What about the case of hurricane hunters? So there are, look at this one, typical La Nina effect. So as you move, you can clearly see fewer hurricanes due to stronger vertical wind shear and the straight winds and greater atmospheric stability, to all the way down to more hurricanes due to less vertical wind shear. That's the kind of platforms and models that have started to come around. So one of the things that we need to look at is precipitation index and climate finance related risks, because extreme precipitation events have increased by 20 to 30% in frequency across South Asia since 1950, that is IPCC AR 62022 reports. Various indices are available, SPI, R95P, TOT, which is talking about the rainfall from very wet days, which is actually talking about the flood risk modeling and your ESG stress testing inputs, very important factor to be taken into consideration. Then you have CDD and CWD, which talks about the longest dry spell and the wet spell duration because of water stress risk in there in the urban zones. SDDI, which is talking about the intensity of daily rainfall and impacting the infrastructure to the storm waters, because all these factors are impacting your ESG related linked finance stuff. It is becoming very important because this precipitation index is mattering a lot, because traditional rainfall, again, data which has been captured in it's actually not capturing your timing, the intensity or the distribution, and all this becoming critical for the crop risk, for the urban drainage systems and the flood insurance. And that's where the precipitation indices, they help you to quantify the hidden patterns and the role of artificial intelligence using various models in artificial intelligence like LSTM. They're used to predict your SPI, then your R95P TOT, which is out here, which is talking about the percentage of rainfall from very wet days. And it is helping you to simulate the future drought scenarios for policy planning and investment purposes. Precipitation index is actually transforming your raw data into more of an actionable insight based on the artificial intelligence models and the GIS-based platforms. It's becoming now essential for everything from crop insurance to health to urban planning to financial instruments. Now, again, coming back to the point of interest for everybody is the various platforms. I'll take you back to this platform out here. Here you can, again, as I said, can play around with extreme temperatures of precipitation index. There are multiple of them. Like I've just taken the case of, the precipitation index. You can also look at, say, ocean heat content, and then they apply it out here. It'll give you a complete detailed mapping out here, what is happening in terms of the ocean heat, since it has been measured since about 1955 till about 2025, how the heat has risen in joules versus the year time period, what has been the 0 to 200 meter ocean heat content, heat in terms which has been measured again in terms of joules versus the time over the time period. So there are multiple such kind of platforms available. One needs to visit to understand the precipitation index, and then one can link it to the various financial instruments across the board. That because since we are talking about the precipitation, that also brings us to another important factor, and that is about the drought. So one of the popular ones that is used, the drought index that is used, is called as the Palmer Drought Severity Index, which is for soil testing, stress testing, and systemic risk, because extreme precipitation events have increased across Southeast Asia, as I said, So your PDSI value has been defined from -4 or less to extreme drought to all the way +1 to +4 with the extremely wet spell. So this has been very clearly defined by Palmer Drought Severity Index. Basically, it was developed by a meteorologist named Wayne Palmer way back in 1960s, which is measuring a prolonged and abnormal soil moisture conditions and the content that is present, and incorporating a temperature rise and the impact on the rainfall, the evaporization of the thing, so that you can have a standardized scale that is going to be used globally so as to monitor your agriculture and your drought and your hydrological drought conditions that might be existing. And that's where, again, the use of AI and PDSI, they have been merged together, the role of artificial intelligence with PDSI forecast severity indexes. So as you can get real-time analysis of the data sets that are coming around using which is really very useful for your early warning systems and climate-linked financial instrument stress testing. One of the cases where it has been used is 2020 to 2022, the mega drought in the western US. PDSI dropped below -7 all the way. That's less than -7 all the way, dropped below, and the lowest in 1,200 years. That was the level of artificial intelligence based data that was generated and scenarios that were generated. So PDSI is actually bridging your climate data to the soil stress, to all the way to the soil moisture, into actionable ESG insights and forecasting based off ESG risk, your agri-finance and resilience planning. And one of the popular platform you can look at for PDSI is one. If you look at this platform, it clearly mentions how the PDSI has been Palmer Drought Severity Index mean currently with all the way back to 2014. So they've done it from 1850 to 2014, and they've specifically mentioned the temporal coverage. You can also download the data. It's in a downloadable file. One can play around with these downloadable files. You get the understanding, the description around what is PDSI, the usage and citations, and what's happening around these areas. So there is a lot of information available for all. What are the variables that are taken into consideration when one is looking at Palmer Drought Severity Index? So a lot of information is available now. This is the kind of data that you would be getting around. One can play around with these data sets, figure out what's happening. This is a very, very powerful drought severity index, and it's very popular across the board. That brings me to another point, and that is about the extreme events like cyclone. It's about quantifying the impact to the financial resilience, because cyclones and extreme matrices, they are backbone of the climate risk quantification. They're transforming the meteorological chaos into investment grade data. And why these are becoming very important? Because cyclone matrices now can help you to monetize your climate risk. They can turn your complex natural events into numbers that will drive your your insurance, your infrastructure planning, your climate-related risk modeling, the climate-related financial information and the instruments that are there. It's essentially for stress testing of your financial portfolios, ESG frameworks. What about the climate disclosure requirements? So ACE is becoming a very ACE, as I discussed a few minutes back. It's becoming a signal of financial risk because ACE is able to capture both the storm duration, the intensity, while making it an aggregated damage potential, because India's west coast has seen about 300% rise or increase in ACE, the 2020 to 2023 period, due to longer and more intense storms. And that's where, it has been used by NDMA and BIS and global insurers, because they're now able to design infrastructure for about 100 years or so, because you now have got flood and the cyclone resilience data, and a failure into taking this information can result in underpricing of their risk, because you're in PDI and the long-term planning is able to track your trend escalations in the cyclone over a decade, which is becoming very critical for the coastal city planning, your port insurance, your ESG disclosures, and the heavy infrastructure projects that are there. One of the popular platforms, again, if I was to use and take it forward from here, is becoming a very popular one, is this one out here. So again, when we look at this, the impact of the hurricanes, as we just talked about a few minutes ago, all the way from a fewer hurricanes with La Nina effect to typical El Nino effect. As we play around with this platform, we can clearly see the impact that is coming around, and that is where one is able to understand the extreme weather conditions, which is where La Nina and El Nino comes into picture. That also brings me to another point, and that is about what about the air that we talked about? It's becoming very important, because the air quality index, AQI, and ESG risk modeling are completely correlated to each other, because air pollution is causing about estimated 7 million premature deaths annually worldwide as per WHO. So anything AQI measurements, anything above, between 0 to 50 is considered as good, to hazardous is 300 plus. It's becoming very, very difficult for people to live in 300 plus conditions. And poor AQI is actually impacting your health insurance, your employee productivity, to the real estate values, popularly being used by the bankers and the insurers in the ESG lending for urban projects, for green bond reporting, your disclosures. Now they are actually being indexed into ESG linked financial products, and understanding the matrices, because your AI and satellite data is being used with AQI monitoring, because the AI models are now being combined with the satellite data such as MODIS or Sentinel, plus with the IoT sensor data for the real-time AQI forecasting, for urban planning, for pollution tax modeling, for health risk estimation. So AQI is no more just about an environmental indicator. It's a hidden driver, or rather, for urban economic risk and ESG linked investment performances. So in terms of the policy and changes that is required, India's National Clean Air Program, NCAP, is targeting about 20 to 30% reduction in PM 2.5 by 2026, and across 131 cities. The SEBI's BRSR guidelines, including your environmental matrices like emissions and the air quality disclosures, and the location-based AQI and disclosure and ESG report. One of the popular platforms that is used for measuring air quality in mapping is this one out here. So here you're able to do your IQ. AIR is one where you can monitor you can see what is happening out here. So when we look at it, what is the quality of the air station, the wind, the fire, everything is being indicated from the very unhealthy conditions to the unhealthy sensitive group. Who's more vulnerable? Where are you vulnerable? You can figure this out. What about the living conditions of the various cities across the world, to the most polluted cities, world's cleanest cities in terms of the air quality, to the cleanest city ranking. This is based entirely on the data that you're looking at. What about the smoking, air pollution indoor versus outdoor? How much is impacting your high blood sugar to obesity? All the factors have been taken into consideration when a platform like this is built around. Another thing that comes around on the similar lines is aerosol depth, optical depth. which is a new lens to the climate and ESG risks, because it is measuring the degree to which the aerosols, that is your dust, your smoke, the pollution, and how is this aerosols preventing the sunlight from reaching the Earth's surface. So people living in Delhi NCR can appreciate what I'm talking about, particularly in the months of extreme winters, then the sun is just down has been covered up with the haze, and that's where AOD levels above 0.5 can reduce solar radiation by about 15%, impacting crop yields, solar energy productions, air quality indices. This is as per NASA and modest data research. It is important because the environmental factors such as high AOD is signifying your poor air quality, leading to your climate altering impacts, your biodiversity losses. In terms of governance, the regulators, they are using your satellite based AOD monitoring systems to inform the air quality compliances, the city level environmental planning. And in the indexed products such as the insurers and the reuse insurers, they are using AOD to price your environmental liability risks in the industrial regions. The investment screening funds by ESG funds, they are excluding regions or sectors which are persistently having high AOD level due to the health and compliance risks. The solar power yielding forecasting is becoming very important because the AOD is affecting your solar radiation forecasts, which is very, very crucial for your renewable energy portfolio. So AOD is just more than a pollution metrics now. It's a predictive tool for climate resilience, for your economic stability, for your ESG compliances, for your ESG linked financial products that are there. One of the popular windows that you can look at, we can use for AOD is NASA Worldwide. So if you go here, you can see, you can add layers out here. Once you start to add layers, you can see what is happening out here is, you can look at the aerosol index. You can include the index. You can look at the UAV aerosol, and it will take you to the maps, which is going to open up, and you can see what is happening. What about the temporal views? How do you do scientific disciplining around it? What the features around it? So whenever you're looking at a hazard conditions, how does your aerosol optical depth take into consideration? Your aerosol optical depth up to 500 nanometers, which is almost real time, to about Armstrong parameter, which is about 440 to 870 nanometers, which is near real time again. So you can look at these platforms, you can look at various disciplinary approaches across the board and how it impacts the health and the energy factors, and what about your ESG linked instruments out there. And that also brings me to another important point, and that is about PM 2.5, which is talking about the exposure, which we've been talking about across the board till now. The PM 2.5 exposure is actually having a very, very severe health impact and ESG risks altogether, because no level of PM 2.5 exposure is truly safe. This is as per World Health Organization, WHO, and every year about 4 million premature deaths are attributed to fine particulate matter, which is PM2. PM actually stands for particulate matter, which is 2.5, with an exposure to it making not just health risk but a material ESG concern. And why does it matter? Because any fine inhalable particles 2.5 micrometers or smaller, which is being emitted from your vehicles and exhausts and industries and construction and the biomass burning, so they are penetrating deep into the lungs and the biostreams. So this is having a direct impact on your mortality and the respiratory illnesses, your cognitive impairments and the productivity losses, because it is becoming very harmful for the urban degradation factors. And that's how the thresholds have been set, because any city that is exceeding your WHO prescribed limits, they are flagged as ESG risk models. The banks and the insurers are using PM 2.5 data to adjust their credit risk in terms of health sensitivity, particularly in the health sensitivity zones. The investors, they are looking increasingly divesting from your industrial projects that have been located into high PM 2.5 zones. And that's where it's becoming very important, because AI models are now looking at it has become more of a forward-looking tool in terms of AI, using your satellite and the ground sensor data to forecast your PM 2.5 levels and integration with 2.5. PM 2.5 is in terms of exposure to urban sustainability indices, about linking the pollution exposure to SDG matrices and human capital impact. So PM 2.5 is not just about the pollutants, it's about the quantifiable risk risk vector for health, for economic productivity, for ESG accountability. And when you align this with WHO and EPA thresholds, it's no longer about the optionality for the future ready institutions. It is becoming an imperative. One, again, I'll take you back to the platform for PM2.5 exposure out here. So if you can clearly see, you can these are very areas where the PM2.5 worldwide view is being presented out here, and it gives you a clear indicator of what is happening, how big is the problem, how big is the challenging is the problem, what is the areas we're looking at. So if I expand this, you can clearly see it across the tableau. You can see, you can play around with this platform, and you can see what is happening in various areas, how they're expanding around. So whether it's a livable, non-livable conditions we're looking at, so these are the important points that is becoming, PM2.5 is becoming very, very important for everybody to look at, and because it is having an impact on your health, your health, your finance, your production losses across the board. Another thing on the similar lines is about black carbon and GHG concentration. Black carbon is about, it's about it's where you're accelerating your glacier melting, especially in the Himalaya region, which is directly affected by, because the regional water scarcity, and which is impacting your agriculture, because any severe public health implications due to 2.5 linkages have been found to black carbon. This is having a GHG concentrations in the various ESG metrics because they're being directly integrated into TCFD aligned disclosures, carbon footprinting, portfolio level emissions tracking from basis of SBTI, that is science-based targets, initiatives, and net zero strategies. So black carbon and GHG concentrations, they are not only environmental threats, they are material and climate financial variables that are shaping your ESG linked credit, the insurance, the investment frameworks, the use of AI and the satellite data and the GIS platforms. They're bringing together the emissions of indexing around and which is becoming very important for in terms of the heart of the future of the finance itself. When you look at the various pollutants, black carbon to carbon dioxide to methane, the impact across the sectors versus the relevance in the ESG factors and the financial signals that are being emitted. So one can clearly understand when one combines all of them together, the importance of black carbon and GHG concentrations across the board. Because we're looking at the black carbon and the GHG concentration, that also brings me to another very important point, the hazard mapping. Now you're going to turn your climate data into more of an actionable intelligence around it, because every dollar invested in risk mapping is saving about $6 in terms of disaster response cost, that is as per UNDDR. And the hazard mapping is talking about your visualization of spatial distribution of risks in terms of flood, storms, droughts, wildfires, heat waves, where you're looking at converting your raw climate data and geophysical data into decision-making tools for governments, for insurers, for investors. Because that is becoming the very important core data inputs for your remote sensing, your satellites, because you're looking at rainfall intensity, which is coming from your NASA GPM, your cyclone trackings, which is coming from NOAA models, wildfire hotspots, it is coming from your MODIS platforms. This is again, AI enhanced forecasting is becoming important because you're able to predict the event severity and the spatial event where it has happened across the board in terms of near real time. You can have crowdsourcing and IoT sensors adopted to figure out, the ground level verification and validation in terms of the various events that have been extreme hazard events that have taken place. The bankers and the insurers are becoming very big, high consumers of this kind of an idea of data, where you're looking at bankers in terms of asset mortgages for portfolio exposures in high-risk flood zones, to insurers who are trying to price the parametric policies based on mapping hazards of the intensity zones, to cities that are targeting your green infrastructure investments, to high heat or high flood areas, to catastrophe bonds, where you're looking at hazard zones which are directly feeding into your expected loss indices or models across the board for reinsurance markets. And the impact and the ROI, when you measure it in terms of the hazard mapping is transforming your climate risk from uncertain narrative into a more of a quantifiable metrics, making the ESG linked financing more precise, more accurate, and more credible. One of the platforms we've talked about in the earlier days as well is this Think Hazard. Let me just take this out here. So if you look at it, let's take the case of urban flooding. So if I was to identify a city such as New York, and if I was to play around it, it would give me a complete understanding of this platform would give me a very good understanding of how the river flooding is going to be, what is the impact of the river flooding versus the extreme heat, to water scarcity, to tsunamis across the board, and it brings you to the various areas where you can zoom around, you can play around with this, you can figure out, in the various spaces of it, you can zoom out again and look at the various areas where it is going to be impacting. Let's take another case, and that is of, say, coastal flooding. Let's take the case of this Bali as a case point. Bali in Indonesia. And then we can look at it again, what is going to be happening in terms of the urban flooding, which is talking about extremely high. If we look at the various the parameters that we, and the good part is that you can also download it in terms of the PDF. The tsunami factor is going to be high. The wildfire is going to be high. You can look at the various zones that have been divided up. You can zoom into the area. If I was to zoom into this area, it would give me a complete indicator of what is going to be happening. And we can look at it in terms of, again, the very specific area out here, which is going to be having a high impact of volcano versus wildfire versus the other areas that are there in Bali. So this is a very good platform to play around with and figure out your climatic data and its importance. So let's take another case of earthquake. If I were to take the case of Tokyo, which is very earthquake prone area in Japan, and if we were to take this thing. Now, if we were to look at it in terms of the river flooding, if I'm just taking the case of Tokyo as a city for earthquake, what is going to be happening out here? The earthquake is going to be very, very high. The landslides are going to be high. The river floods, which we didn't see in case of Bali or New York, because they have taken the various geospatial factors into consideration, the geographical factors, how it's happening, and they have applied the use artificial intelligence, because extreme heat is going to be low, while the water scarcity, again in case of Tokyo, is going to be low. However, there will be areas, in particularly in the sub-Saharan African areas. So if I was to take one of these areas, Goa, and I can zoom it out here, and I can clearly see that what is going to be happening. So that's the kind of platforms we are looking at. They are becoming very popular across the board in terms of the production of various information around these systems. Let's take the next point, that is about integration of the multi-hazard information and how do we link it to the risk intelligence and pricing of the capital flows. Now, if you see, the hazard mapping is turning a climate data into an actionable risk intelligence platform. So every dollar invested, $6 saved. So that's what we are looking at. So you have the multi-hazard analysis, the multi-hazard intensity zones, and the risk matrices, expected losses calculations happening all the way, because that is going to give us the insurance pricing. Now look at the flying in terms of the fire to the weather risks and the various cyclones out there, because the hazard mapping is going to give you the multi-hazard integration to your risk scoring, to your financial decision making is going to be the thing. Because multi-hazard integration is talking about combining your multi-hazard data sets such as flood, cyclone, heat wave, drought, wildfire into a unified risk exposure, where you're capturing a compounding of the effect in terms of the drought, heat wave, stress, power grids, impact, the flood, the cyclone, and you're incorporating your temporal overlaps all the way to seasonal or multi-year hazard cycles and the geospatial correlations of the same region or to the multiple regions across the board. This is helping in terms of your insurance pricing, because you are having a multi-hazard portfolios which has been diversified or concentrated risk across the board, and changing the various pricing strategies and retention levels. The risk-based premium, where a higher integration prediction of hazard scores with the higher premiums or the reduction in the coverage limits is taking place, the parametric insurance models which is triggering out your payouts based on hazard thresholds from the multi-hazard monitoring, to the underwriting precision where geospatial hazard is overlapping to improve your asset level underwriting. So the impact on the investment allocation, capital allocation shifts in terms of investment away from your multi-hazard regions towards the more resilient, low-risk geographies, to the green finance flows, which is directing your funds to climate-resilient infrastructure, to your sovereign risk assessment, which is talking about country-level hazard scores across which is going to be influencing your bonds, your credit risks, and credit ratings, and the cost of the capital of borrowing. That is what is multi-hazard integration all about. That brings me to the end of this 7th lecture of the lecture series. My name is Atul Tripathi, and I am an honorary adjunct fellow at National Maritime Foundation. Thank you.